Hello, hello. So today on Let's Code, I figured we would talk about an article that I just read because while I usually don't go over these kinds of things on the channel, I feel like one of the reasons that I don't touch on things like this on the channel is because I kind of know what to take seriously and what not to, or what is accurate and what isn't. And it occurred to me that not everybody might have the same kind of view that I have when reading these kinds of articles. And going through this might give you a better understanding of how I think about Rust in comparison to other languages that I use. Because I really don't view any one language as kind of the best. I don't really put myself into the kind of like in-group and out-group. Like I'm not a Rustation for life kind of thing, like that's not me. I'm just like, Rust is a tool that I have found to be very useful, that I really enjoy using, but I've also really enjoyed using other languages like JavaScript or Haskell or other random languages for various reasons. So I thought we would just go through it and I would tell you what I thought as we went through the article. So the article's in InfoWorld. It's called 7 Reasons to Love the Rust Language and 7 Reasons Not to. Throughout the article, they kind of use this love versus hate approach to things that I don't think is very helpful. So we'll kind of call them like positives and negatives as we go over it. It starts off with, love it or hate it, Rust is taking the world of systems programming by storm, which, I mean, it kind of is. It's been years in the making, right? I mean, Rust has been a thing for, I think, over a decade now, technically. So it's like overnight success over a decade in the making. It's being used basically everywhere these days. I don't know if we're going with Fang or Manga or whatever the top tech company group for stock index acronym is, but they're all using Rust in production, and a lot of them are building SDKs and things like that. Microsoft has a Windows SDK for Rust. AWS has an SDK for Rust that's official, etc., etc. So Rust is seeing a lot of success and a lot of usage in production, and it's growing in general. I don't know that I call it a modern successor to C and C++. I mean, it can be used like that, but that's just kind of one facet of Rust to me. Like, for example, when we talk about memory safety, right? If you're used to using like JavaScript or Python or something, you don't even really understand, or you don't have to understand what memory safety is. It's just kind of a given. New languages are memory safe, whereas C is not. So Rust being memory safe is kind of a selling point for people who are currently writing C, but the rest of the programming world has kind of moved on and like they already live in a memory safe world. So I think it's just one piece of it. So it seems a new programming language is invented every day. Yeah, I mean, like there are languages all over the place. But like I said, Rust has been around for over a decade now. So it's not like Rust came out last year and is suddenly being used in production everywhere. This is kind of funny. A programmer gets a flash of genius and then sets out to create something fresh and wonderful. I don't know that that's how anything is created in the programming language world. I feel like programming languages are not flashes of genius, but like very long, like hard marathons of work. But I don't know, maybe other people disagree with me. Goes on to say Rust certainly fills a niche. It's aimed at helping systems programmers and others who want to create code that juggles dozens, thousands, or even millions of events simultaneously. I guess. I don't know. I feel like this is so vague that there's no way to address what it actually means. Building these systems is challenging enough. Building pretty much any system is challenging. And squeezing the bugs out of them is even harder. Turns out you can't squeeze the bugs out of all programs. All programs have bugs. There are some that we can get, but all programs have bugs. Rust turns all the deep theoretical thinking about the best ways to create systems into a living, breathing, useful language. I think that Rust takes a lot of influence from newer research than other languages have, but that's due to the fact that Rust was created later, right? Like, if you were creating a language in 1990, you'd have access to the research from like the 80s and the 70s. So that would influence the language you created. If we think about Rust as being like a decade old, Rust has access to like the 2000s and the 90s of programming language research. So like all of the deep theoretical thinking, I think it takes advantage of newer research. I don't think that it takes advantage of all of the research. I think I don't think Rust is like the end all be all of languages. I think it's a great language. I think it's very useful as a language. I do not think it is the uh, pinnacle of perfection of programming languages in any way. There will be a language after Rust at some point. Rust's core team runs a developer survey each year. In 2021, for the first time, more than half of all Rust programmers were using the language on the job. I don't know what survey they're talking about here, but sure. I mean, if you are a Rust like community organizer and you query the Rust community that you organize about who's using Rust in production, you're going to get people who use Rust in production. It's not that surprising. No, it is like one of the I think it's the most loved language on the Stack Overflow survey, like 7 years running or something like that. But like, don't put stock in surveys. Like, it's nice that that's a thing. I'm sure the people that work on Rust appreciate that in some way as kind of like a recognition of their work. But like, all surveys are flawed. So don't use that as like facts that disallow you from using other languages or something. So we've got a love to start off with, a positive. Rust tackles scale and concurrency. Sure. I guess like what doesn't would be my question. Like what modern programming language doesn't try to tackle scale and concurrency? They go on to make some like arbitrary claims like many consider Rust the best language for building tools suited for today's architectures. Like sure, some people consider like Node the best tool or Elixir or Erlang or whatever. Like you will always find people with an opinion if you are looking for people with an opinion. The web browser is a good example of an application that requires massive scalability. Is that true? I don't know that I would phrase it like that. It's a big, complicated piece of software, a browser is, but like massive scalability? That's a odd way to phrase it. So it's no surprise that Rust was created by Mozilla. It was not created by Mozilla. It was adopted by Mozilla. I'm pretty sure Graydon created the language on their own, and then Mozilla decided to like fund it, but I don't think Mozilla created it. I could be wrong. I'm not a Rust historian per se. So we have a negative next. Rust's concurrency model is too complex. While multi-threaded systems are growing more popular, many developers don't really need them. I mean, if you don't need multi-threading, then don't use multi-threading, is my contest there, right? Like we've built a bunch of CLI applications that are not multi-threaded, or serverless functions that are not multi-threaded, or whatever, right? Like you don't have to write multi-threaded applications if you don't need to write multi-threaded applications. And they go on to like port their point by saying web developers can write PHP code. Sure. Yeah. You could use any language. Like use the language that you like. Go. Yeah, like definitely. But I don't know that that is supporting their point very much. I also think that like serverless programmers write one function and lead the hard work to someone else. It's kind of like throwing away other people's hard work. Developers who need to create more sophisticated web applications can turn to Node.js, which offers another strategy for tackling multi-threaded applications. Does it? They go on to say Node's event-driven model married with promise-based code can produce results that are simple and elegant. Yeah, but that's async await, which Rust also has. So like a lot of languages have async await these days. If you're saying that it's a negative for Rust's concurrency model, then the concurrency model from the developer perspective is the same, right? You're writing async functions and you're using them. They make a claim here that Rust's multi-threaded programming model is more sophisticated than many programmers require, and you could like ignore those, but some programmers would rather not deal with the complexity at all. I would rather see an example of what they think is more complex than other ecosystems. I think that all of the async code that I've seen is like of the complexity of async code. That's kind of inherent to async code, right? Whether that's in Node or Rust or somewhere else. Rust is a modern language. If they mean that it uses research from the 90s and 2000s to become a language, then yeah, wonderful. I like that too. But so does like other languages. Like JavaScript didn't get created and then stop evolving. Most of programming language design today focuses on creating functional languages that guide the coder into writing software that's easier to analyze. Is that true? I would love to see a reference for that. I think that languages are moving more in a functional direction in general, but like, I don't know that for a fact. Many developers love Rust's logical functional syntax that encourages structuring their code as a sequence of nested function calls. I guess they're pointing to like Rust being an expression-based language here, or maybe they're thinking of something more like the builder pattern. So I'm not really sure exactly what they're referring to here. Although the builder pattern wouldn't be nested function calls. It would be sequential function calls. They go off about how Rust creators wanted something or whatever. I would usually just ignore stuff like this unless the person that's speaking has a context and a history that gives them insight into that. Like if they were somebody that worked on the Rust language, that would give them some standing to be like, oh, when Rust was created, when I was there and around and working on it, whatever. But if they're not there, then like attributing intent to people that you are unfamiliar with is a dangerous game. But they go on to say, to build something that could handle the bit-banging low-level programming required to keep Internet of Things functioning. I don't know if that's true. I don't know that IoT was a big driver of Rust. Rust embedded stuff is a big category now, but I don't know that Internet of Things was a driver for the Rust language. Rust offers the right combination for programmers looking to tackle these very real challenges with modern style. Okay, so they basically say Rust is a modern language. I don't know how you could disagree with that in general, you know? Like, it's modern. It was created after the year 2000. Like, okay, whatever. I don't think that's a huge thing. Negative, it has a steep learning curve. I hear this from a number of people, and I think that quite often it is a couple of things. So I'm an educator. I teach people how to write Rust. So I have strong opinions about this in particular. I don't think that Rust has a steeper learning curve than any other language. I think that learning new concepts and ideas and methods of working is always hard. And if you think back to when you learned your first language, I think that you would find that that was very hard. And if Rust was your first language, it would not be any harder to use Rust as that first language than whatever you learned. So it has a steep learning curve in the same way that like programming stuff in general has a steep learning curve, but it's not any more steep by being Rust than by being something else. And they do mention that a little bit. They say that like if you are a career programmer and you've been working in a certain way, say you've been writing C or something like that, and you're moving to a memory safe language, that requires kind of giving up some of the control that you might be used to when writing C and letting the compiler kind of deal with that. As an example, Rust requires abandoning the ideas of scope and ownership. That is just like factually incorrect, which are required by older languages like JavaScript and Java. I would very much disagree with that as a statement. Like Rust has scope and Rust has ownership. So like I don't really agree with that. If you want to leverage Rust's benefits, you have to be willing to relinquish some familiar features that can lead to bugs. That can be true if you're talking about something like C, and you are used to like manually bit banging pointers around or something. Rust language syntax is also complex. Some would say too much so. I'm sure you could find somebody that would say any language is too complicated. People certainly say that about C++ and also JavaScript. So I'm pretty sure you could find people that could say that about anything. It's not just curly braces or curly brackets and parentheses anymore. Square brackets, vertical lines, the greater than symbol all make an appearance. That seems pretty dramatic. JavaScript also has curly brackets and parentheses and square brackets, like array access, vertical lines. Are they talking about like closures? They're talking about like anonymous function definitions and the greater than symbol. Like, come on, really? That's a really weak argument. Sometimes there are even double colons because one colon isn't enough, apparently. This feels like a weird shot at Rust's module paths. I get like if you don't like double colons in your module paths, then like, okay, you can have that opinion. I don't think it's any more weird than any other way of dealing with paths. Like JavaScript is mired in like a decade-long transition from what was kind of like no module system to Common JS, which kind of got standardized in Node.js, and then ES modules, which kind of got standardized in like 2014, and we still haven't really converted the industry over to. So like I don't know that that is a better situation in any other language. Rust developers who are building complex, multi-threaded tools may see Rust's syntactic complexity as a worthwhile trade-off. I don't think it's any more complicated than other languages. True fans. Let's just ignore that. We'll ignore the fact that they're calling anybody true fans. Who grok the functional flow may even enjoy it. Like, sure. I think anytime you start talking about true fans or whatever you're about to say is kind of baseless. Learning all of Rust's semantic rules is not for the casual user. That's true for any language. Like, if you think about JavaScript and you think about like knowing all of the semantic rules, you can easily go onto YouTube and find a video that is like JavaScript, what WTF, what does this code even do? Like, there's a lot of rules in programming, especially in like the way that language features combine, especially when programming languages have existed for 2 decades or more. Like, learning all of the semantic rules for an entire language, for any language, is like not a casual user thing to do. You can use a programming language without knowing all of the rules. We have got a positive here. You can tell the Rust compiler what to do. Let's see what they mean by this. Some developers see all the extra details and boilerplate required by Rust as an advantage. I guess, like, if you're going to say extra details and boilerplate required by Rust, like, you have to say something. You have to give an example, right? So they don't give an example, so there's no way for me to be like, oh, no, it doesn't, or yes, it does. Like, there's nothing for me to check. Like, there's no way for me to be like, yes, this is correct, or no, it's not, because they don't actually give any details. It lets them inject hints that make it easier for the compiler to figure out what is going on and catch any potential bugs. I guess they're talking about the type system. The ornate code is a better chance for the developer to fully specify what is supposed to happen, which helps with avoiding compiler errors. Rust invites developers to write better, faster code by injecting hints about how their code should work. I don't really know what they're talking about here. They're either talking about the type system or like maybe attribute macros or something like that. Or like you can have an attribute macro or like something that says, hey, inline this function. But that's a fairly common like programming language tool. Dislike, who wants to tell the compiler what to do? Some developers just want a language they can use to bang out loops that run without crashing. This feels weird to me. Like, if you want a language that you can use to bang out loops that run without crashing, but you don't want to tell the compiler what to do, then the compiler has to infer that using something based on the code that you've written. So you're always having a conversation with the compiler anyway, if there is a compiler. They want a language that handles the background work so they don't have to worry about it. If the compiler sometimes produces code that's a bit slower or maybe a bit buggier, that's okay. It's interesting to me that they say, or maybe a bit buggier, but above they want it to run without crashing. So like bugs cause crashes. So what language is this? I think get the sentiment, like the high level idea that they're trying to get at here. Like, some people just want to write JavaScript or something, right? They want a scripting language that doesn't really have a compiler that they can just like ship to the browser and run. And if we never execute the code path with the bug, then it doesn't technically like have a bug or whatever, you know? But I think this more deeply comes with a level of familiarity. Like, some developers just want a language they can use to bang out loops that run without crashing. That to me feels very much like some people want to write in a language that they are intimately familiar with and comfortable with. So if that language is Rust, then this is that language. If it's not Rust, if it's something else, if it's JavaScript or whatever, or Python, then it's JavaScript or Python. I think this is saying I want to be familiar and comfortable with my language. I don't want to. We've got another positive. Rust has great backward compatibility. That is fairly true. Rust programs from compiler version to compiler version don't really break. You can write a crate with the 2015, 2018, or 2021 version of Rust, and it will still compile using that version of the compiler from that edition. So that's really great because you can write a bunch of Rust code and it is going to work in 3 years. I do have to say that in my experience with like writing JavaScript, that can be not true. So it is nice to have that in Rust. I do like that about Rust in general. Dislike, Rust is not strictly object oriented. Didn't they just say earlier in this post that the world is moving towards functional programming? So like, if they like that it's a modern language that's moved towards functional programming, then how do they also not like that it's not strictly object oriented? I feel like they've said both ways in this post. Like they've said, the world is moving towards functional programming, but also Rust is moving towards functional programming. And we like everything moving towards functional programming, but we also don't like Rust moving towards functional programming. So like, I don't know. This feels like a direct contradiction of something that they said earlier in the post. Rust asynchronous processing model is safer. Safer than what? Right? Like we have already gone over that like JavaScript has async await as well. So like safer than what? I don't know that I can't think of any way that Rust async await like programming model is inherently safer than any other. I might be able to stretch that into like the Rust language helps me like manage memory more easily and stuff like that. Or like using the Rust feature of like ownership, but that's ownership and stuff. That's not like the asynchronous processing model. That's a separate thing. Dislike, asynchronous coding is hard. Nothing Rust does can save us from having to think carefully about our code. Yeah, I mean, like, nothing is going to save you from having to think about your code and write your code. Rust can't protect the code from deadlocks or delays. It can only offer better advice and a less buggy structure. I don't know what they're really saying here. Like, no, we haven't solved the halting problem. Like, you know, as an industry, that is a standing issue. So no, nothing can do that. Developers are still responsible for good application design and writing clean code. I hate the words clean code. I know I've been saying like negative instead of hate for this entire post, but like legitimately, if you tell me that some code that I wrote is clean code, I'm going to press you for like what specifically you mean about that, because it's a meaningless set of words. And worse than that, it's a meaningless set of words attached to some pretty negative worldviews. It would be nice if Rust were a magic wand, but it isn't. Yeah, I mean, if you have a magic wand, give me a magic wand. I'd love to have that. Rust just minimizes problems and reduces some of the more obvious dangers. I don't know. Asynchronous programming is hard. Yeah, sure. It's hard in Rust. It's hard in JavaScript. It's hard in Python. It's just hard. Of programming without abstractions. Who's programming without abstractions? Are you programming without abstractions? Because I'm not. I use abstractions all over the place. Rust was built to support system-level programmers who write low-level byte-tweaking code. I guess, in a way. It offers access to the raw bits and expects the programmer to use it. Okay, so it offers access to the raw bits. Sure, take that. That's fine. And expects the programmer to use it. That is not true. The way that Rust is written as a language is Rust has become a high-level language that allows you to peel back the layers of abstraction and work at lower layers if you need to and or want to for various reasons. So you could write a Rust program that looks a lot like a JavaScript program, right? Or a TypeScript program, since the typing is probably a more fair comparison there. And if you want to determine how the bytes of your structs are laid out on disk, you can, but you by no means have to, right? And Rust doesn't expect you to. Rust has a bunch of defaults that make it act as a nice high abstraction language. Dislike, byte level access is risky. Sure, I guess. How is that a Rust thing though? Like if you don't want to do byte level access, if you don't want to use unsafe code, then like don't write it. You can forbid using compiler errors, all unsafe Rust in a program using the unsafe Rust forbid like attribute macro or whatever. Like this is not like byte level access is risky, yes. Using unsafe code is risky, yes. But you aren't doing that day to day in most cases. And if you do have to do that, then it's very clear that you're basically painting that area of your code base with like bright red paint going, hey, this is the area you need to check if there's a bug. And again, you don't have to deal with the details of allocating memory and representing data. It's not like you're gonna go, Hey, give me 8 bytes. Hey, give me 4 more bytes. Hey, give me 16 bytes, please. Like you're not manually allocating like set numbers of memory and then turning that into like a string with a struct or something. I don't know. Like, I don't know. This doesn't pan out for me. Positive, a better way to do garbage collection. Many popular languages handle internal memory allocation and garbage collection for you, which is a nice service until the garbage collector stalls everything. That's a thing that I've heard that happens. If the JVM decides to stop the world, or like you have too many objects in JavaScript and you have to garbage collect them or something like that. They go on to say that like, hey, having garbage collection in like a medical device is really scary. And like, yeah, I could see that. You really don't want your like pacemaker to, not be able to pacemake because it's garbage collecting. The Rust language has its own approach to memory management that's not as comprehensive as traditional GC, but can be more powerful. Again, it feels like this is just like not as comprehensive. Okay, according to who? That's just like your opinion, man. But like, whatever. I don't know. I would love to see more concrete examples in this article. A good developer can deliver great performance using Rust's memory model, but they've got to master the type system and atomic reference counting. I mean, like, mastering the type system, fine. Rust is a typed language. But like, why do you have to master atomic reference counting? It's like they're saying if you don't use arc, the data structure, then you haven't like properly optimized your Rust program. I don't know. This feels weird. For diehard Rust fans, hands-on memory management is a feature they love. Hands-on memory management? I don't feel like I do hands-on memory management in Rust. I don't know. Maybe some people are, but I don't feel like I'm doing that. I guess in the embedded world, you could be doing more of that. That would make more sense. But that's not like that's not a feature of all Rust programs, I don't think. Also, something I'll mention here is that Rust doesn't like get rid of garbage collection. It just moves it to compile time. So like while in JavaScript or something, you might accumulate a bunch of objects and then the GC has to run at runtime. In Rust, you already know when all of your objects are going to come into and out of scope. So you like Rust, the compiler knows when you need to allocate memory and then release that memory. And that happens at compile time when you compile your program, which is great because happening at compile time means that you can check some of that stuff. Memory management is a pain, apparently, as a negative. Many popular programming languages have implemented internal memory management because it prevents memory leaks and other bugs. It prevents memory leaks? I don't think that's true. I'm not a Java expert though, so like somebody that knows more about the JVM can leave a comment. I'm pretty sure you can leak memory in Java. Like I'm pretty sure that you can leak memory in like any language. So shrug. Most programs don't need to worry about an occasional hiccup caused by garbage collection. Sure. I don't know what they are talking about as most programs, but sure, whatever. We'll accept that. As a programmer, you might prefer not to have to worry about memory. You don't have to worry about memory in Rust either. Like if you're writing an embedded application, you're probably not doing it in a garbage collected language anyway. So like this feels like a kind of a false equivalence here. Rust isn't the only language offering an alternative to traditional garbage collection. Node.js, for example? What? Node.js, for example, simplifies multi-threaded coding and lets you rely on JavaScript's runtime memory management. It stalls occasionally, but if your users don't mind, then it's a good compromise. I don't think that Node.js is an alternative to traditional garbage collection. I think Node.js has garbage collection. Conclusion, but on that note as well, if JavaScript works for you, then use JavaScript. It's fine. Like there are so many languages and so many programs to write. Like use the thing that works for you. Conclusion, Rust is still new and evolving. That's your conclusion? We can debate whether Rust offers the best model for asynchronous coding. We already covered that it basically has the same asynchronous model as other languages. Whether getting rid of garbage collection really helps the developer. Again, didn't get rid of garbage collection, just kind of moved it to compile time, and so on. But in the end, Rust is still a very new language. I don't know. Rust has been around for over a decade at this point. Calling Rust a new language is like, I don't know, new to you maybe. But Rust is like, to be clear, Rust is now in the Linux kernel as the second language to be used in the Linux kernel. It's being used by all of the major tech companies. It's being used by startups. It's being used across new industries and old industries, and it's in production, and it has been for a while for a bunch of people. I don't know that I would call Rust new in that sense. And all languages hopefully are evolving. That is kind of a feature of programming languages that are used. The right way to create Rust programs is open to debate. Sure, write things in the way that works for you. Rust may or may not be the best language for you or your project. It may or may not be the best solution for creating software generally, but it's an exciting option with plenty of opportunities for exploration. As a language, Rust is novel, and learning it stretches the brain. I'll say this. I don't think Rust inherently is a novel language. It doesn't do everything in a novel way. It doesn't take advantage of, like, I think really esoteric research. Like, it doesn't have dependent typing or anything like that. So, like, it's not really novel in that sense, I don't think. Like, it uses pretty established research. But on the other end, if you have not worked with its ownership model, that could be a novel concept to you. So I wouldn't say that Rust, the language, is novel per se. I would say that perhaps pieces of Rust are new to you if you are going to learn it. And that's it. They just kind of like end with Rust, maybe or maybe not. Who knows? So yeah, I don't know. That's how I read this kind of article. Maybe that was interesting for you. If you're still on the video, clearly it was. So let me know that you finished this video, and maybe I'll do more of these kinds of things in the future. But yeah, that is how I read these kinds of articles. I think that in general, this article is kind of like Rust is a thing, and therefore people talk about Rust. I don't know that this article in particular had any novel insight, is the way that I'll put it. I wouldn't send this article to somebody and be like, hey, you should use Rust because I read this article. There are probably better ways to do that for your situation, you know? Like if you're building something with like WASM and GPU stuff in the browser, maybe send them a different article that talks about how Rust is good for like building WASM and GPU stuff, or like an example of the WGPU crate or something. But yeah, I probably wouldn't send this article to anyone. So if you enjoyed that, let me know. And if you have other articles that you would like me to go over, feel free to leave them in the comments, and I may or may not make videos on them. But I just wanted to share kind of my like approach to reading this kind of stuff, and my approach to like taking what people are saying in the wider world, and assigning some weighting to it to determine what I'm going to do in the future when it comes to Rust or JavaScript or some new language or something like that. And I will catch you in the next video. As always, have a great day.